Welcome to another episode of Dominic Does DIY. In this episode, we're going to continue kind of discussing the MOSFET and how it's used as a switch, except this time we're going to go into a little bit more actual real world, and we'll be able to see something happening as opposed to just looking at PSpice simulations, LT-Spice simulations. So what I'm going to use is an Arduino relay shield, and so we're going to come to understand how the MOSFET is used as a switch. We want to control these relays with a microcontroller. But if we look at a microcontroller, and this is just the FET Mega, the 2560, the same thing that's on an Arduino Mega 2560. So if we look at the data sheet on this, we can kind of see these absolute maximum ratings right here. And we can see that the current per pin is only 40 milliamps. Right? So that means any pin can drive 40 milliamps. And the max current for VCC and ground pins, meaning the most that it can sink, is going to be 200 milliamps. So we want to make sure that we do not exceed those things. However, if you look at the relay data sheet, so these are the relays that are on my Arduino Shield. And if you look at the data sheet right here, mine is a 5-volt relay shield. And if we look at the maximum rated current on this, we can see that at 5 volts, nominal voltage, our rated current is going to be 90 milliamps. So we cannot actually drive this directly with an Arduino because we cannot push enough current in order to make it happen. So how do we do this? We control the relay with a MOSFET and then control the MOSFET with a microcontroller. So let's take a look at this and see how it is that we can make this work, the code we have to write in the Arduino, and then see some activity of the relay switching on and off so we can kind of see what's going on. So as always, like, subscribe, share, comment down below if you like, and let's get started. So to begin with the Arduino relay board, what we have is, and I know I said I wasn't going to do LT-Spice, but this is just to show you the schematic because I couldn't find a schematic of the Arduino shield. So what basically is happening is we have an Arduino shield and it has a relay on it. This is a 2-form C relay, which means it has a normally open and a normally closed contact with one shared common. This relay is then powered by a coil. Usually the coil resistance is measured in resistance, even though it acts like an inductor. So let's take a look at the data sheet and just see what I mean. So here we can see the coil resistance. It is listed in ohms, but in reality it is an inductor. But the way that the inductor works, and after it saturates, they basically have a constant current draw and it works like a resistor. So we can see that the coil resistance on this is about 56 ohms on the coil. So I just put an inductor here and threw in some inductance, but realistically, this was 56 ohms. And of course, I'm not going to run this, so I can fill it in with bogus information. What they're also going to do is they're going to stick a diode here. It's the recirculating diode. So the same thing that we had on the H-bridge. As soon as this coil de-energizes, when we shut off this MOSFET, this inductor needs to do something with that energy. And so just like we had that recirculating diode on the H-bridge, we also have to put a recirculating diode across the coil of this relay. So the Arduino board would have, the Arduino shield would have a diode right there going across the coil. It has an NMOS, probably a 2N7000. It has a pull-down gate resistor to make sure that the MOSFET is always off. It has a resistor here to the GPIO pin to kind of protect a current surge. And then this would be the GPIO would be the point of contact that connects to the Arduino. So anytime the Arduino pin goes high, it would turn on the MOSFET. The MOSFET would allow current to flow through K1. When current flows through K1, the coil becomes energized and the relay switches from the normally closed contact to the normally open contact. When the GPIO goes low, the MOSFET turns off, the inductor will de-energize itself through the recirculating diode, and when it is out of energy, the relay will then switch back to the normally closed contact. So common to normally closed contact. And that is how the Arduino shield works. It's got 4 of them on this particular shield. So how we're going to see the switching from the normally closed to the normally open contact on the relay is we're going to hook up this circuit. We're going to go from 5 volts through a 220 ohm resistor. We're going to have the red LED connected to the normally closed contact, and we're going to have the green LED connected to the normally open contact, and our common is going to connect to ground. So at any moment in time, one of these LEDs will be lit. It'll either be the red or the green. And we can get away with the one resistor because they can't be on at the same time. This is a break before make relay. And 220, I just picked 220, 330, 1K. I'm not really going for a specific current. I just know that 220 is going to be pretty low, like maybe 20, 30 milliamps or something like that. So I went ahead and soldered the green and the red LED with the 220 ohm resistor in the common anode configuration. So the 2 anodes of the green and the red LED are connected together to the 220 ohm resistor like in the schematic. And then the other 2 leads will go into the normally closed and normally open contact of the relay. So you can see here, I went ahead and then connected those dual LEDs to the Arduino. And I connected the red one to the normally closed contact. And I connected the green one to the normally open contact. And then I had the 220 ohm resistor that was on the anode of both those LEDs going back to the 5 volt rail, as you can see right there. And then I just took the common with a couple jumpers, the common of the terminal block, and wrapped it around and went into the ground terminal of the Arduino Mega. So now that we have the LEDs connected and everything hooked up to the Arduino, we are going to go ahead now and basically write the intro code. So this is just some basic beginning Arduino stuff just to kind of make sure that everything is working as expected. And so all we're doing is I use a lot of pound defines in my applications just because I want to be able to change things easily. I want to be able to use, Arduino uses a lot of pin numbers and in a lot of their function calls, and I prefer using names. So I've got relay 1, 2, 3, and 4, and those relays correspond to the GPIOs 7, 6, 5, 4 respectively. I also want to have a switch, which we'll find out in a second, and the relay in it. We will just go ahead and I like making init functions. So basically, I can have one function call that kind of handles everything that I want to do at the start. Usually these things are done in Arduino code in the setup. Usually these things are done in the setup portion, but even in the setup portion, I like to still call init functions. So our relay init, we're going to just put all the pins as outputs, and we're going to default them all to low so that they are in their off state or their normally closed position. And we're going to make that switch as an input, and we're going to use the internal pull up. This is so that I can just pull it to ground to make things happen. So as you scroll down, the setup's pretty easy. Since I like to always have some sort of serial out, I always use the serial at 115.200 so that I can talk out, and I just do some basic stuff, right? This is just going to say system start. I should make it setup start, and then we'll initialize the system, and then we will go to print out setup complete. So we kind of know what's going on. If it halts in there for whatever reason, we know. Second, you can ignore this. This is unnecessary right now, so we'll just get rid of it. And so basically what we have here is on that switch, so long as it is grounded, if I get it pulled low, remember it's internally pulled up, so it should be high unless acted upon. So if it goes low, then go ahead and basically, this is my long code to toggle the relay in Arduino land. There might be a toggle button, a digital toggle. I don't know, but this does the same thing. It's basically going to write out to relay 3 if under the condition of read relay 3. If relay 3 is high, then go low, else go high. Same thing with 4. So you're going to write out to 4, and it's going to take a look first, what is 4? And if 4 is high, then go low, and if it's low, then go high. So I don't know if you've ever seen this shorthand before, but this is basically a quick and dirty if-else then statement to set something of some value. Then we are going to go in and go ahead and add a little bit of a delay and wait for them to release, right? And the reason why that is because we don't want this microcontroller is going to work a lot faster than we are. So we just want to make sure that we don't have any debounce. And that's what that's going to hope to clear up. And this one right here is going to basically wait until we release it before we try pushing another one again. So we should have one click of the system here. So let's go ahead and program this. So here's our Arduino setup. I got done programming it. And again, apologize for any shakiness because I'm going to be moving the wires. But I got done programming it. So right now our default state is in the normally closed position. And so if we zoom over, you can see that the diodes, the LED that's lit up for the normally closed position is lit up, and the normally open one is off. And then we go over here and you can see I went into pin 12. My switch was on pin 12. So now all I have to do is ground this pin right here, and we should see the LEDs turn off. So my ground is that black wire right there. So if I just touch it, and so you see how it's flipping back and forth? What's even worse is if I drag it, right? I'm getting debounce and nastiness going on. And I'm not doing anything. I'm just dragging the wire across the other one. And so that's what I was talking about, the debounce that was in there, that delay of 50 milliseconds. And even my wait to release the switch function was not really working. It's because this is kind of a sketchy setup with the wire setup. So what I'm going to do is I'm going to wire in a switch. And of course this is a joystick function, but it also has a clicky switch capability. So I'm going to wire that in for pin 12. So give me 1 second. Okay, so now I got my joystick connected up. This joystick in particular, when you look at it, when you look at this joystick, you can see that it has ground, 5 volts, and a switch along with your X and Y outputs. But I just need the switch part, so I just wired that part up. And now when I push the switch, you can see we get a nice clean. It's not always clean. If I hold it in, sometimes it'll trip out still. So there it goes. You saw the doubler, it went on and then off. I'm just clicking one time though. But you can see that this cleared up the issues a lot. So I can hold it in, no problem, release it, go to the next one, call it good. Oh. And every once in a while, it does act funky. So, but for the most part, yeah, it's pretty good, right? This probably has something to do with, I've got a bunch of loose wires right here, probably non-ideal connections going on between pin 12 on this thing. But it definitely cleared it up a lot by using an actual switch rather than me dragging the wire. So I've seen with the circuit how it is that we actually use the microcontroller to control a MOSFET, to control a relay, which will then allow us to do something as an output. Now you may be thinking, it's just a red and green LED. But this is just for a functional application. Like what do we use this for, right? Well, these relays, because they're not connected to your circuit and it's just making some contacts, you can have these things turn on any type of electronic. So you can have it turn on a light, you can have it turn on your radio, you can have it turn on your massager, right? Because all you're doing is you're making a contact between 2 points. So you're able to turn anything on. These relays are actually rated, even though they're on an Arduino board and you think DC, they're actually rated for 125 volts, which means you could plug in line voltage to it and turn something on in your house. So the next thing that we'll do is actually to make this even more useful, right? Actually not more useful, but useful period, right? Because right now we're just kind of experimenting with how to turn the relays on and off. But what would be even more beneficial is if we could turn these things on with, like, let's say a remote, right? So that would be even more interesting. So now that we've seen how these relays work with the click of the button, right? So now we can understand, oh, the Arduino, the MOSFET, the relay, all that good stuff. The question is, what do we use these things for? Well, actually, these relays are actually rated for 125 volts AC. So you can actually see here that they're rated for 24 volts DC or 125 volts AC, 3 amps either way. That means we can actually hook this up to a regular light, a monitor, a computer, a radio, anything that's plugged into AC. We can actually hook this up and use those contacts to break and make contacts to supply power to the system if we wanted to. But it's not very useful with just this switch doing it. What would be more useful is if we could have like a remote control do this. The next video we'll be working on making that happen. I have here, it is a bluetoooth. It works off of AT commands that connects to this Arduino. I have this other board over here, which is just ESP32 LilyGo with a couple things. So you can see I've got the relays written there. My icon isn't that great, but in the upper right hand corner, let's see if we can actually see it. So if I tilt it right, you can actually see the screen a little bit, and you can see that there's a Bluetooth icon, there's the word relay, and actually if I get it right, you can see I got a little picture of some relays to tell you if it's in the normally closed or normally open position. But if now I push this button, you can see one of these controls one of the relays, and the other one controls the other one. So if I push this top one, it'll flip the one on the left, and if I push the right one, it'll flip the one on the right. And of course, the way that our code is written, if I push the button now, they will be off sequence toggling. So next time, we'll explore how it is that we can use the Bluetooth and some AT commands and then work towards this ESP32 so that we can come to make our remote control relay switcher. And as always, thanks for watching, and see you next time.